So our objective will be to determine whether one number is a factor of another, or whether a number is divisible by a certain number.
Yes.
Who needs more time with the objective? Okay. We will get into the divisibility rules, but to introduce it, one of the other math teachers found this video, so we're going to watch it and just kind of see how a couple of the divisibility rules work. Let's see if this will work from the iPad. It's not seeming like it. There we go.
Obviously, I've brought along my number file playing cards. Other playing cards are available, but these are the best ones. Okay, so just, well, you know what number file playing cards is, isn't he? Of course I thought that. I'm always at the top of the pack, Brady. There is you, of course, so they can watch. They're just here to watch. I'm also going to let Matt watch, because Matt is the sort of king of number file card tricks, right? So, okay, so I've just taken 9 cards, okay? The first, all the clubs, basically, all the numbered clubs. Here's the challenge to you, Brady. I want you to put them in any order you like. I'm not even going to pay attention. Let's go. That'll do.
Oops, sorry. Let's turn it up a little bit.
Obviously, I've brought along my number file playing cards. Other playing cards are available. I mean, 1 in 3 numbers is a multiple of 3. I've given you 4 cards.
Oh.
Right, you can put them in any order. Just make me a multiple
too
of
far
3.
up. Let's go back a little bit.
You know, it's about it.
There
It's
we go.
even. It is even, yeah? Do you think it's... So it's obviously not prime, then? Do you think this number's in the 9 times table?
Probably not. Doesn't feel like it is.
Yeah, I mean, 1 in 9 numbers is in the 9 times table, right? So it's... You might think it's unlikely. Should we have a bet? Okay, I'll bet you a pie, right?
All right.
So you're saying it's not. I'm going to say it is.
All right.
Okay, so should we check?
Yeah.
Okay, let's check, right? So, okay, so we put the number in, divide it by 9, see if we get a whole number. Oh, yes, we do. Okay, now do you want to go again? Do you want to try again? You can even take it. You can take a number out if you want.
Any number I want?
You take out any number, right?
All right. Well, let's take out
And
the
do
top.
double or quits, right?
Let's take out the top number.
Okay, you're taking out the top number, so you've been left with this number.
Yeah.
Okay, do you reckon this is in? You can rate. Do you want to move them around a bit?
Yeah. Let's swap the 5 and the 4. There we go.
You sure are you done?
All right, so if that video was confusing, we're going to talk about it. But if you caught on to what they were doing, they kept calling it the cross sum, but adding up the numbers or the digits of their bigger number was a big thing they were doing. And then seeing if that was divisible by 3 or 9. That was the big idea there. We're going to talk about it more in a minute. First, what 2 numbers multiplied together give you a product of 12? Dominic, what do you think?
2 times 6.
Okay, 2 and 6 would be one option. So 2 times 6 would be 12. We would have other options like what? 3 and 4 would be another option. But if we're sticking with this option,
I think
we need to keep our comments to ourselves while we're going through notes. If we're sticking with this option, divide 12 by one of those numbers. Which one do you want to divide it by?
6.
Okay. And 12 divided by 6 equals 2. Now, of course, these number relationships are something that you should have been familiar with since, I don't know, probably like 3rd grade at least. Right? 3rd or 4th grade is sometimes 2nd grade. We start seeing some multiplication. So we're going to talk about some definitions. I feel like this one's misworded a little bit. The blank of a whole number divides that number with a remainder of 0. So the factor, there's a S missing. The factor of a whole number divides that number with a remainder of 0. So to be a factor, you need to divide with a remainder of 0. Divide into it evenly, sometimes we say. A whole number is divisible by that factor if there is a remainder of 0. So this whole idea of being a factor or being divisible by all hinges on the fact that there's a remainder of 0. If we have another remainder other than 0, it's not a factor, or the number is not divisible by that factor. Okay, factor and divisibility are terms we should have at least heard before. So let's get into those rules. A number is divisible by 2 if the ones digit is divisible by 2, or if it's an even number. If it's an even number, it'll be divisible by 2. Here's one of the ones they mentioned in that little video. It's divisible by 3 if the sum of the digits is divisible by 3. So for the example he was using, he was adding up the numbers 1 through 5. 1, 2, 3, 4, 5 equals 15. 15 is divisible by 3. That's what he was talking about in the video. A number is divisible by 4 if the last 2 digits form a number divisible by 4. Okay, so that would be something like 312. The last 2 digits are what? 12. The last 2 digits are 12. 12 is divisible by 4, so this whole number should be divisible by 4. Okay. Number is divisible by 5 if the ones digit is a 0 or 5. A number is divisible by 6 if it's divisible by 2 and 3. There is no rule for 7, so we're skipping over 7. If you put a 7 in the next blank, you should erase it. A number is divisible by 8 if the last 3 digits form a number that is divisible by 8. Okay, so it's kind of like the 4's rule, except this time it's got to be the last 3 digits divisible by 8. A number is divisible by 9 if the sum of the digits is divisible by 9. That one was also mentioned in the video. And it's divisible by 10 if the ones digit is a 0. All right, determine whether the number 146 is divisible by 2, 3, 4, 5, 6, 8, or 10. And if it is, we're going to explain why. So, is 146 divisible by 2? How do you know? Okay, you could tell me that it's an even number, or that the ones digit, which is a 6, is divisible by 2. So you could tell me 6 is divisible by 2 because that was the ones place. Is 146 divisible by 3? No, why not? Why is it not divisible by 3? Well, what's our rule for determining if it's divisible by 3? Deontay?
It says that the sum of its digits is divisible by 3.
Okay, sum meaning we do what? Add. Okay, so the digits of 146 are 1, 4, and 6. So if we add 1 plus 4 plus 6, what do we get? 11. Is 11 divisible by 3?
No.
So 11 not divisible by 3. All right, is 146 divisible by 4? Why not? The what? What are the last 2 digits? Okay, so 46 is not divisible by 4, so the whole number is not divisible by 4. What about 5? No, why not? Okay, so 6 is not 0, and 6 is not 5. The 1's digit would have to either be 0 or 5. What about 6? No, why not? Well, careful. It was divisible by 2, but it's not divisible by 3. So it's got to be divisible by both of those. So if it wasn't divisible by both of those, then it's not going to work. What about 8? Well, what's our rule for 8? Okay, so this one isn't super helpful this time because there are only 3 digits there. So if we were to try to do our long division on it, how many times does 8 go into 14? Once. Bring down the 8, subtract 14 minus 8 is 6. Drop your 6. How many times does 8 go into 66? 8 times. 8 times 8 is 64. We end up with a remainder of 2. So if we have a remainder, is it divisible by that number? No. So you could say no. You could say 146 not divisible by 8, or gives a remainder. Gives a remainder of 2, something along those lines. Question?
Do you have to write the that? Because it only says if it's yes and reason why.
So I'm going through all the reasons so that you could see if I tell you to explain it either way, then you can see that. Okay, so yes, if this were a question on a quiz or a test, and then the if yes part would be different. But if it just says explain, so if I were to change the whole directions to just generically be explain, you'd have to be able to do this. Okay?
So are you going to have the rules part on there?
No, you got to know the rules. That's why they're in our notes, so we can study them. What about divisible by 10?
Absolutely.
Why not?
There's not, the one's digit is not 0.
Okay, 1's digit isn't 0 would be a good explanation. Questions about using those rules? Okay, so let's use a different number. So state what 39 is divisible by, use the rules. So we will just write down what it is divisible by on this one and explain why. We won't actually write out the why nots this time. So is 39 divisible by 2?
No.
You should be able to tell me why not. Or even if we're not writing it, you should be able to tell me why you're saying no. Okay, it's not an even number, so we're not going to write down a 2. Is it divisible by 3?
No.
Yes. What's our rule for 3s?
Rule 3 is divisible, 12 is divisible by 2.
How'd you come up with a 12?
Yeah.
The sum of the digits, so 3 plus 9 equals 12. And 12 is divisible by 3. So therefore 3 would work. What about 4? No. Okay, here's a helpful hint. If it's not divisible by 2, it definitely won't be divisible by 4. Okay, what about 5?
No.
No, why not? Okay, 1's digit isn't a 0 or a 5. Is it divisible by 6?
I don't think so.
Why not? What's the rule for 6? Okay, the number has to be divisible by 2 and 3. Did we write down 2 on our list?
Yeah.
No, this one wasn't divisible by 2, so it can't be divisible by 6. Okay, now 7 there isn't a rule for, but this is not divisible by 7. Will it be divisible by 8? No, a number like this, there aren't even 3 digits to check, but you should know that 39 is not one of our multiples of 8. Next one, 9, is it divisible by 9? No, when we take the sum of the digits we got 12, is 12 divisible by 9? Nope. Last one to check is 10. No, why not? One's digit isn't a 0, so that's the only number that belongs on our list. Questions about what's going to be a factor of 39? Okay. Let's do one that's a little more interesting, 118. Will it be divisible by 2?
Yes.
Why? Okay, even number, or you could say 1's digit is divisible by 2. Is it divisible by 3?
No.
Why not?
Isn't it something?
What's the sum here?
10.
Okay, sum of the digits is 10. 10 is not divisible by 3, so 3 does not belong. What about 4?
I don't say.
Yeah.
What's our rule?
Yes.
Okay, what are my last 2 digits?
18.
18. Is 18 divisible by 4?
Absolutely. No.
No! 18 is not divisible by 4, so neither is this number. What about 5? No, because the 1's digit is not 0 or 5. Is it divisible by 6? More than 2 people should be answering these questions. For it to be divisible by 6, what 2 numbers does it have to be divisible by?
2 and 4. 2.
2 and
3.
3. It was divisible by 2, but was it divisible by 3?
No.
No, so will it be divisible by 6?
No.
No. Okay, 7 there's not a good rule for, so we'll move on to 8. Is it going to be divisible by 8? Okay, if it's not divisible by 4, it won't be divisible by 8. That's another good rule to go by. Or you could show out some long division. 8 goes into 11 once. Drop your 8, but this one it goes in 4 times, and you do end up with a remainder of 6, so it's not going to be divisible by 8. What about 9? Why not 9? What's my rule for 9? Dominic?
If the sum of the digits is divisible by 9.
Okay, we already talked about what the sum of the digits is. What is it? We add them up. What's the sum? 10. Is 10 divisible by 9? No, it's not. So, what about 10? Why is this number not divisible by 10? 1's digit isn't a 0. So this is another one that's not very exciting, not divisible by much. Okay, we're going to state if 876 is divisible by our list of numbers using our rules. Start with 2.
Yes.
Why?
It's an even number.
Okay, even number, 1's digits divisible by 2. Okay, what about 3?
Yes.
Why?
Sum adds up to 21 and 7 times 3 is 20.
Okay, so 8 plus 7 plus 6 is 21, and 21 is divisible by 3. What about 4? So what's our rule for 4? Okay, so the last 2 digits are what?
76.
76. So is 76 divisible by 4?
Probably.
So 4 goes into 7 how many times?
Once.
Subtract, you get?
I'm
3. Drop your 6. How many times does 4 go into 36?
6 times.
Somebody said it. Somebody was saying the wrong thing too, though. How many times does 4 go into 36? 9 times. 9 times 4 is 36. So our remainder is 0. So is our number going to be divisible by 4? Andrew, what's the answer? Yes. Yes, because 76 was divisible by 4. Okay, what about 5? No, why not? 1's digit is not 0 or 5. What about 6? Yes, why? Okay, 876 was divisible by 2 and divisible by 3. So if it's 2 and 3 are on the list, 6 has to be on the list. What about 8? Well, what's our rule for 8? We look at the last 3 digits. That doesn't help me out a whole lot. But if we look at the last 3 digits, it should be apparent pretty quickly. How many times will 8 go into 8? Once. 0. How many times does 8 go into 7? 0 times. 0, 7, drop the 6. Does 8 go into 76 evenly?
No.
No, it doesn't. So we could put 8 times 8 here, 64. We'd get a remainder. But even once we're trying to see, does 8 go into 76, we should already be able to say, no, it's not going to work out. Okay? Oh, we could have done 9. Sorry. Back that up. 972. Either way, we're getting a remainder of 4 there. Okay. So 8 doesn't work. What about 9? The rule for 9 is similar to the rule for 3. How do we know if it's divisible by 9?
I don't think so.
Why not?
What, is it the sum thing?
Something. What was the sum of the digits?
21.
Is 21 divisible by 9?
No.
No, so it won't be divisible by 9. Is it divisible by 10?
No.
Why not? The ones digit is not a 0. Okay, questions about our divisibility rules? Okay, then let's move on. An expression like 5x is called a, we should know this. How many terms are there?
Oh, one of those monomial.
Monomial. Okay, we should have already known this.
I didn't, not two S's.
Okay, so recall that a monomial is an integer. Monomial is an integer, a variable, or a product of variables. Did we skip over? Oh, we skipped over a little bit. We'll go back to that. So, examples of monomials, we've already looked at some of those. I guess this is just a refresher because we've already done a lot of this. Examples of monomials would be things like 5. We already saw 5x. We could have 5xy cubed. Things like that. Non-examples are things that are not monomials. Would be things like 5 plus x or 5 minus xy cubed. Okay, those are not monomials. More than one term there. So let's jump back up right above that. In your notes, it said something about we know 5 and 12 are factors of 60. You see that? Right above our definition 3. Okay, so if 5 and x are our factors, 5 times x would equal 5x. That's where we led into this. Should just be a 5x in there. So we're filling in all the blanks. Okay, so determine whether each expression is a monomial. Do we think A is going to be a monomial? No. What if we distribute? If we distribute, is it a monomial then? No, okay, because of that plus sign. So it's not a monomial either way. No, not a monomial. What about letter B? Yes, this one is a monomial. We're just multiplying all those together. Okay, that's a little review. I think we did these notes in a different order last year, which might be why this doesn't match up. So the big idea today is our divisibility rules. So we're going to have a worksheet on that.